So in this video, we're going to look at the proof of the summation of the first n terms of a geometric series. So the problem says a geometric series has first term a and common ratio r. Prove that the sum of the first n terms of this series is given by Sn equals a times 1 minus r to the n over 1 minus r. So quite a common proof. And whilst more often than not you will just be using the formula in a question, they could ask you to prove the formula as well, so you do need to know how to do this. So our starting point is to write out what we actually mean by the sum of the first n terms of a geometric series. Well, our first term is a, because it's a series we're adding each term. So the second term would be a times the common ratio r plus a times r squared plus a times r cubed, and so on, up to a times r to the n minus 2 plus our final term, our nth term, a times r to the n minus 1. Remember, the minus 1 is here because the first term is just a, it's not ar. That's going to be our first line. The next line we want to write is the same summation, but we're going to actually multiply it by r. So we're going to write r times Sn. So all the terms are the same, we're just multiplying by r. So our first term would be ar, the second term would be ar squared plus ar cubed plus ar to the 4 plus dot 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 plus ar to the n minus 1, and the final term for this one would be ar to the n. And that's going to be line 2. And what we're going to do is we're going to do the first line, subtract the second line. So we're going to do 1 minus 2. Now if we do that, we've got Sn minus r times Sm is equal to, and if you notice, what's going to end up happening is the ar is going to cancel, the ar squared is going to cancel, and so on. And all that we're going to be left with is the first term from the first line, so a, minus the last term from the second line, ar to the n. Now to both these lines we can take out a common factor. So for the first line we've got Sn times 1 minus r. Here we can take out the common factor of a, the first term, so 1 minus r to the n. And finally, we can say that Sn is equal to, if we divide by this 1 minus r, a times 1 minus r to the n all over 1 minus r. That's the form that we're looking for, and that's the proof. Now, there is a little bit of a trick to help you remember this one, and that's actually from the formula to move this as a multiplication on the other side. So actually you can generate what this line is working backwards, and then if you expand, because that's actually telling you that in order to find this, you need to know what Sn is, and you need to know what r times Sn is. So it gives you a little bit of a hint, but make sure you show the stages in the correct order. Okay, but it's a little bit of a clue in case you forget how to do this proof if you're panicking in the exam. That's how we show this proof.